practice set 2.2. First example, the question is show that 4 root 2 is an irrational number. We have to show that 4 root 2 is an irrational number, and here how we have to prove that? By using indirect method. By using the indirect method we have to show that 4 root 2 is an irrational number. So here we have to start with an assumption. So what assumption we have to consider here, or what assumption we have to write here? Whatever we have to prove, exact the opposite of it we have to consider, we have to assume. So here we have to prove that 4 root 2 is irrational. So we will consider that 4 root 2 is rational number. We will consider that 4 root 2 is rational number. And then we have to prove that our assumption is false, our assumption is wrong. So here first we will write the assumption. Here we can write let 4 root 2 is rational number. Let 4 root 2 is a rational number. It is an assumption. Now, if it is rational number, we can represent it into a upon b form, or into the p upon q form, or into the x upon y form. If it is rational number, then we know that the definition of rational number. If a is any integer and b is any non-zero integer, then a upon b is rational number. If p is any integer and q is any non-zero integer, then p upon q is rational number. So here if it is rational number, you can represent it into the a upon b form. So here we write, therefore 4 root 2 is equal to a upon b. Since it is rational number, that is our assumption, so we represent this rational number into the form a upon b, where a and b are the having only one common factor, that is 1. They do not have any other common factor. So here it is too easy. Just we will transfer this 4 to the right side. So what you will get here? Root 2 is equal to a upon b into 4. Sorry, into 1 upon 4. Or you can write it into the denominator only, a upon 4b. Here 4 is in the multiplication, and if we transfer it, it will went into the division. So you can directly write a upon 4b. So here a upon b is rational number. 1 upon 4 is also a rational number, and we all of you know that the product of the two rational number is always rational. The product of two rational number is always rational. Simply we can write it as root 2 is equal to a upon 4b, which is a rational number. Here a upon 4b is rational number, and root 2 is irrational. Yesterday only, in the previous lecture, we proved that root 2 is irrational number. We already proved that root 2 is irrational number. Now how is it is possible that left side is irrational and right side is rational? Here left side is irrational and right side is rational. How the right side is rational? Since a upon b is rational, 1 upon 4 is rational, the product of two rational number is always rational. So it contradicts our assumption. It is not possible an irrational number and a rational number is equal. That is impossible. So it means that the assumption which we assume here, or which we consider here, that is incorrect. So you can easily write that here LHS of this equation is irrational and RHS is rational, and which is impossible. So it means that our assumption is false, or it is incorrect. So what is correct then? Then it is correct that 4 into root 2 is irrational number. If the consideration assumption is incorrect. So here we write first a upon 4b. is rational number, and here you can simply write LHS is irrational. LHS of equality, you can say it as equality or you can say it as equation. LHS of this equation is irrational and RHS is rational, which is impossible. Here LHS is irrational and RHS is rational, which is impossible. Which is impossible. That is not possible in an equation. LHS is irrational and RHS is rational. That is not possible. And rational number and irrational number is never equal. So here we can write which is impossible. It means that why we get this impossible equation here? Since our assumption is wrong, our assumption is false, our assumption is incorrect. Since we get this impossible equation here, which is not possible, but we get that equation here since our assumption is incorrect. So you can write here, therefore above mentioned assumption is, therefore above mentioned assumption is false. Above mentioned assumption is false since we get this. Now above mentioned assumption is false, it means that 4 root 2 is irrational number. So you can write here, therefore 4 root 2 is an irrational number. That is what we have to do. This is very simple, this is very easy. Now we will take the next example, that is example number 2. Second example from practice set 2.2. The question is, show that 3 plus root 5 is an irrational number, and we can easily prove that 3 plus root 5 is irrational. But here again we have to use the indirect proof. So first of all we have to start with the assumption, and what we have to assume? We have to assume exactly the opposite of which we have to prove. Here we have to prove that 3 plus root 5 is irrational. So we will consider that 3 plus root 5 is rational. So here we will start with an assumption, let 3 plus root 5 is a rational number. And since we consider that 3 plus root 5 is rational, we will write it as 3 plus root 5 is equal to A upon B, that is in the form of A upon B. We can represent any rational number in A upon B form. So this is a rational number of 3 plus root 5 and we represent it in the A upon B form. Now here we have to transfer this 3 to the right side. Why? Since we have to get LHS irrational and RHS rational. Here if we put this root 5 as it is and we transfer this 3 to the right side, we will get A upon B minus 3. Nothing is there in the denominator, means we have 1. A upon B minus 3, or simply you can write this 3 as A upon B minus 3. Root 5 is equal to A upon B minus 3. Now here A upon B is rational number, 3 is a rational number, and we know that the subtraction of the two rational number is always rational. Subtraction of the two rational number is always rational. So here RHS is rational and LHS is irrational, which is again impossible, or you can say that it is contradictory. It is contradictory means it is wrong, it is false, it is incorrect. चुकीचा आहे असं आपण म्हणू शकतो. It is not possible that an equation having LHS irrational and RHS rational, which is impossible, which is contradictory. So here we can write LHS of LHS is irrational, LHS is irrational, and RHS is rational. RHS is rational. LHS is irrational, that is root 5 is irrational number. And here RHS, A upon B is a rational number, 3 is another rational number, and we know that the subtraction of the two rational number is always a rational number. So totally together A upon B minus 3 is a rational number and root 5 is irrational. Since LHS is irrational and RHS is rational, which is impossible or which is contradictory, which is impossible, or you can say which is contradictory, which contradicts that our assumption is wrong, which contradicts that our assumption is wrong. Here 3 plus root 5 is rational. Since impossible, root 5 is equal to A upon B minus 3 is not possible, since LHS is irrational and RHS is rational. But we get that. So it means that we get the impossible equation here. Why we get this impossible equation? Since our assumption is wrong. Why we get this impossible equation here? Since our assumption is wrong. So you can represent here. Above mentioned assumption is false. Therefore, above mentioned assumption is wrong. Above mentioned assumption is false or is wrong. Therefore 3 plus root 5 is irrational number. 3 plus root 5 is an irrational number. So this is all about the example number 2. Now we will take the next example, the example number 3rd, but we have to use compass there and it will take too much time. So first we will take the example number 4, and then into the next video lecture we will take the example number 3rd. So it will take a lot of time, much more time. So we will take the question number 3rd after question number 4. So now we will take the example number 4 from the practice set 2.2. Example number 4 from practice set 2.2. The question is, write any 3 rational numbers between the two numbers given below. In each and every example we have given the 2 rational numbers and we have to write the 3 rational numbers between these 2 numbers. And as we all of you know that there are infinite rational numbers, there are infinite rational numbers between the given 2 rational numbers. There are infinite rational numbers between the given any 2 rational numbers. We studied this part from the 7th standard, that there are infinite rational numbers between the given 2 rational numbers, and here we have to write only 3 rational numbers between the given 2 rational numbers. So here we will take the first example. In the first example we have given the 2 rational numbers, that is 0.3 and negative 0.5. We have given the 2 rational numbers and we have to write the 3 rational numbers between these 2 numbers. Here, how to get the 2 or the rational number between the 2 rational numbers. Infinite rational numbers are there, but how to get that numbers? That is very important, and there we have a technique. But we are not using that technique here. We will directly write the 3 numbers, but we will discuss what is that technique, what is that method to get the infinite rational numbers between the 2 given rational numbers. Suppose you have given 3 and 4, and you have to write the infinite rational numbers between the two rational numbers. So here what we have to do, we have to take the sum of these two numbers and we have to divide that sum by 2. So you will get a number between these two numbers. Now suppose if you take the addition of these two numbers, that is 3 plus 4, it is 7 divided by 2, which is equal to 3.5. This is a number between these two. This is a number between these two, that is 3.5. Between these two, we have 3.5. Between these two, we have 3.5. How we get that number? Adding these two, 3 and 4, and dividing that sum by 2, we get the number between these two. Now here we get one number only. Now between these two, we will get one more number. Between these two, we will get one more number. Now here how we will get this number? Adding these two. 3 plus 3.5 divided by 2. 3 plus 3.5 divided by 2. 3 plus 3.5 is 6.5 divided by 2, which is equal to 3.25, which is equal to 3.25. Here we will get one more number between these two. 4 plus 3.5 is 7.5. 4 plus 3.5 is 7.5 divided by 2, that is 2 3s are 6, 1 carry. 2 7s are 14 and 2 5s are 10. So here you will get 3.75. Now between these two, you will get one more number. Between these two, you will get one more number. Between these two, you will get one more number. Between these two, you will get one more number. So like this we will get. Then between these two, between these two, then between these two, between these two, between these two, between these two, you will get infinite numbers between the given two rational numbers. But here we are not using this method. You can use that method also, but it is taking too much time. We have a simple option to write the three rational numbers. Only we have to write three numbers. There are infinite numbers between the given two rational numbers. Only we have to get three rational numbers. So you can use this technique also here. Take the addition of these two divided by 2, you will get the numbers between these two. Then sum of these two divided by 2, and then sum of these two divided by 2. Three numbers we get there. You can use that method also, and we have a simple option. We have a simple option to get the three rational numbers between the given numbers. So how you can get easily the three rational numbers between these two? Here we have 0.3. So you can simply write that 0.3 as 0.30. You can simply write this 0.3 as 0.30. And here we have minus 0.5. You can simply write it as minus 0.50. You can take 0. We have single digit here only. You can take 0 there. We can take number of 0, so many number of zeros, but we take only 1. Actually no need to write that 0 also. Directly you can write the three numbers between these two on the number line. On the number line, on the rough page you will write these two numbers on the number line, and then you will write the numbers between these two. There are infinite rational numbers. We have to write only three rational numbers. Actually here no need to take 0 also. Then we have to take 0, and why we have to take 0 we will discuss later. But here this is the bigger number, this is the smaller number. So on the number line, see, this is just for your kind of information. Don't need to draw that diagram here. Here minus 0.5 means, see, this is the smaller number. Since it is negative, this is the smaller number out of these two. So we write it into the write it to the left side of the number line, and this is positive number, so here we will write 0.3. Now before 0.3, now numbers between these two, we can easily write all the numbers between these two. Before 0.3, 0.3 is there. Before 0.2, 0.1 is there. Before 0.1, 0 is there. Before 0, which numbers should be there? Here we have minus 0.5. Before minus 0.5, minus 0.4. Before minus 0.4, minus 0.3. Before minus 0.3, minus 0.2. Before minus 0.2, minus 0.1. And then we have 0. So you will get lot of numbers there, but we have to write only 3 numbers. Look at this diagram, you can easily get the numbers. Before 0.3, what we have? 0.2. Before this 0.1. Before this 0. Now here before 0.5 minus 0.5 we have minus 0.4, then minus 0.3, then minus 0.2, then minus 0.1, and then we have 0. Then we have 0 here, then 0.1, 0.2, 0.3. How many numbers are easily get? 1, 2, 3, 4, 5, 6 numbers we get, and we have to write only 3 numbers there. But it is very important that which one is the bigger number and which one is the smaller number, and how to write the numbers between them. Once we write these numbers on the number line, it is not necessary to draw the number line here. It is not necessary. Do not draw that number line there. This is just your kind of information. So we cannot write the wrong numbers there or the numbers between them. How you will get the numbers between them? Since this is positive number, we will write here 0.3. Since this is negative number, we will write to the left side, that is minus 0.5. Now here before 0.3, not after. Before 0.3, you can take 0.2 there, you can take 0.1 there, you can take 0 here. Now before minus 0.5, it should be minus 0.4, minus 0.4. Then before minus 0.4, it should be minus 0.3. Before minus 0.3, it should be minus 0.2. Before minus 0.2, it should be minus 0.1, and then we have 0. So here we easily get how many numbers we get? Is 1, 2, 3, 4, 5, 6, 7. We get 7 numbers between these two. Actually there are infinite rational numbers. But we need only 3, so you can use this technique also with the help of number line. Why we draw the number line here? Since one number is negative and one number is positive. Now sometimes students make mistakes. What they write after 0.3, they write 0.4, 0.5. They are after 0.3. They are not between these two. If you write 0.4, it is wrong. Since 0.4 is after 0.3, that is not between these two numbers. This 0.4 is not lies between these two numbers. Since we take the help of number line, actually no need to draw the number line there. No need to draw the number line here. You can directly write the numbers. But while the numbers which we write are correct or incorrect, to know that for our guidance, number line should be there. You can draw that number line on the rough page, and you can easily get the 3 numbers between the given 2 numbers. Or one more method you have, take the sum of these two and divide that sum by 2. You will get one number. Then you get the numbers between these two. Then sum of these two divided by 2, sum of these two divided by 2. You can easily get the 3 numbers between the given 2 rational numbers. So here you can use any method. By using with the help of number line, you can write the numbers between these two, Or we have one more method, that take the sum of these two, divide that sum by 2, and you will get a number between these two. Then take the sum of these two divided by 2, then sum of these two divided by 2, you will get the third number. So you can easily get the three numbers. Now here you can write, simply you can write how many numbers we have to write. Since we have to write the three numbers between the given two numbers, and we already get which numbers are there, since this is bigger number, this is smaller number, you can easily get the numbers between these two, and the numbers are 0.2, 0.1 and 0. You can write minus 0.1, minus 0.2, minus 0.3, minus 0.4 and then minus 0.5. So here are the numbers between. Are the numbers between 0.3 and minus 0.5 and minus 0.5. So this is all about the first example. Here we write the three numbers between the given two rational numbers. Now we have second example. We have given the numbers minus 2.3 and minus 2.33. So here after decimal sign we have only one digit, and here we have two digits after decimal sign. So here also we will take second digit as 0, and you can write minus 2.3 as minus 2.30. Why we take this 0? Since here we have two digits after decimal sign, and here we have only one digit after decimal sign. So we will write this number minus 2.33. Now you can easily write the numbers between these two. So put these two numbers on the number line. No need to draw the number line here. This is for your kind of information only. No need to write the number line here. But just which number is greater and which one is smaller. To get that, we have to use the number line. Here this is the greater number, minus 2.30, and minus 2.33 is smaller one. So here we will take the bigger number at the right side, that is minus 2.30, and here we will take the smallest number, that is minus 2.33. So before minus 2.30 what should be there? See here, minus 2.30, then 31, 32, and then you will get 33. We get only two numbers. See, minus 2.30, before minus 2.30 what should be there? Before minus 2.30, minus 2.29, minus 31, then 32, and then we have 2.33. We get only two numbers there, but we have to get three numbers between these two. So we will take one more 0 here, and we will take one more 0 here. Since we are getting only two numbers, so we take 1 0 here and we take 1 0 here also. Now after the decimal sign we have 3 digits here and we have 3 digits here also. But this number is equal to minus 2.3 only. This is not different number than 2.3. It is minus 2.3 only. You can take zeros there, and due to this 0 the value of that number is not increasing or not decreasing. That is very important thing. We will get the same number. Now here we have minus 2.33, we write it as minus 2.33, and you take 1 0 there, since we have 3 digits after decimal sign, and here also 3 digits after decimal sign. So now here we have minus 2.300, which one is bigger, and minus 2.330, which one is numbers there, and we can easily write that numbers. Here this is the bigger number, and this one is smaller number, minus 2.3. So see here, suppose we remove these two signs. Now this is smaller one, this is bigger. 2.30 is, if the minus signs are not there, 2.3 is bigger one, and 2.3 is smaller one, 2.33 is bigger one. And if we put the minus sign there, now here this one is bigger and this one is small. This one becomes bigger and this one becomes smaller due to this minus signs. Now here we have to write the numbers between them. Now here we have minus 2.300. So what should be there before minus 2.300? Minus 2.301, then 302, minus 2.302, then 303, 304, 305, 306, 307, 308, 309 up to 330, means we get 29 numbers there, and we have to write only 3 numbers. So here you can write, see, look at this diagram again. Look at this diagram again and see this 2.300. Before 2.300, after here not before, after 2.300. Since we have 0 of the positive numbers at the right side only, both the numbers are negative. So we have to write here 301. 302, 303, 304, 305, 306, 307 up to 330. So here we can easily write the 3 numbers, that is minus 2.301, minus 2.302, minus 2.303 are the numbers between is minus 2.3 and minus 2.33, minus 2.3 and minus 2.33. So this is the answer of the second example. Now we have to write the answer of the third example. In the third example, here we have 5.2 and 5.3 are the given rational numbers, and we have to write the 3 numbers between them. So here lot of students gets fumbled, since after 5.2 only 5.3 is there. So how you will get the 3 numbers between them? So here we will write 5.2 as 5.20. We take a 0 here. Since the value is not going to increase or decrease, we take 1 0 here, and we write 5.3 as 5.30. And now you can easily write the numbers between them. 5.2 is 20 is smaller, 5.30 is bigger. So numbers between these two, here no need to draw the number line also, since both the numbers are positive, you can easily write the numbers between them, that is 5.21, 22, 23, 24, 25, 26, 27, 28, 29. You can easily write the numbers between them, since both the numbers are positive, you can easily write the numbers, or you can take the help of number line. Since here one is positive, another is negative, here both the numbers are negative, we take the help of number line here. We have no need to take the help of number line. You can directly write the numbers, that is 5.21, 5.22, 5.23 are the numbers between 5.2 and 5.3. 5.32 and 5.3. Then we have last example, that is example number 4. We have given 2 numbers in the example number 4, that is minus 4.5 and minus 4.6. Now here also it is 4.5 and 4.6. Suppose these signs are not there, then this one is smaller, this one is bigger. But if we put the signs, negative signs there, now this one becomes bigger and this one is smaller. This one becomes bigger and this one becomes smaller. So both the numbers are again negative. We will take the help of number line. Here we will draw the number line. At the right side we have to take bigger number. Which one is bigger? Minus 4.5. To the left side we will take the smaller number, that is minus 4.6. Now this minus 4.5 you can write as minus 4.50. Minus 4.50. You can write this number minus 4.5 as minus 4.50, and you can write this number minus 4.6 as minus 4.60. So here we have 50, here we have 60. Now minus 4.50. After minus 4.50, that is minus 4.51, 52, 53, 54, 55, 56, 57, 58, 59, and then 60. So you can easily write the three rational numbers between the given two rational numbers, and those numbers are minus 4.51, minus 4.52, minus 4.53 are the three numbers. Are the three numbers. Are the numbers between. Are the numbers between minus 4.6 and minus 4.5. So this is all about the example number 4. Here we solve all the 4 examples from this question, and till the third question is remaining, which we have to take into the next video lecture. Thank you.